Hello everyone, I am Jhalak Upadhyay. I'm a final year bachelor student from India, and I have mentored last year in GSOC with FOSSASIA, where I developed this Flutter application for Badge Magic from scratch. So it was a very exciting project. Once I saw this project on the when I was searching for different organizations for GSOC, I saw this project. It took me around a week or two to understand what the basic structure for this is, and then I presented my proposal and somehow got selected, and and then the rest is a very good journey. So I'll probably move ahead with what I'm going to present. So the agenda for today is I'll be giving you a high-level understanding how images are being handled in Flutter. So there can be multiple ways to handle these images, but I'm going to show you the way that I have handled it in Badge Magic. So the first agenda is this, and the second one, I'll be giving a high-level overview of how Badge Magic image handling works, how we are processing the images, how we're transferring to the badge. So you'll probably get a pretty good idea about how to get started on this Flutter application, because handling images is I would say the critical part, because handling text is very easy. You should, wherever a person gets stuck is handling images. So if after this, you'll probably get a high-level idea of how you are going to proceed ahead. And maybe you can improve how I'm doing this. So yeah, so there are different image representations in Flutter. So I'll go ahead with each one and try to give you an understanding of what is the functionality of each of them. So first one is UI.image. So UI.image is basically a library that is in Dart, and it's a very low-level library that directly interacts with the native functionalities of the image. So for any image to be rendered on the screen, it cannot be in compressed formats. We probably need to have it in a format that GPU can render it and show it on your display. So in Flutter, the Dart provides UI.image as the way to present these images on the screen. Okay, so I've added the main uses, like we can use custom painter. Custom painter is basically how you design your UIs customly. So we can use UI.image to sort of paint the UI on a painter, and then can display it on the screen. So it stores raw image data for GPU processing. So that's what I explained you before. And yeah, so the images, like I said before, the images like PNG and JPG, they are in really compressed formats. The GPU will never be able to render them. We need a particular format, a decompressed format, where we get access to each of the pixels of the image. So that's where the UI.image comes into picture. So we just take the compressed images, we pass it into a kind of decoder, and decoder gives a UI.image for it. Okay, let's go ahead. So yeah, but the thing with the problem with UI.image is since it is decompressing the images, it takes a lot of space. So we need to be very careful while using UI.image, so that we should not use too much space, because it's going to capture the main memory space while running. So suppose, let's say image is kind of 1,000 by 1,000 pixels, let's say. And for each pixel, we are taking 4 bytes. So it's going to be around 4 MB of space for one image. So that's a lot of space in memory, actually, for an application, and for application like this one. So yeah, this is it. So yeah, we would actually need to be very careful while using UI.image. And one more thing, yeah. So one more thing that we need to do is that it does not have garbage collection. So we'll probably need to dispose it every time we use, otherwise memory leaks are often very common. And so UI.image is a class, but we need a data type to somehow represent those pixel datas. So that's where uint8list comes in. There are other representations also, but uint8list is most commonly used, and that's what I use. So maybe there could be a better representation for it also. So we just, I've just showed you a small code section. It's from Badge Magic actually. So how we are actually you're getting the byte data for the image. So we just call the constructor .toByte data, and it sort of gives us the uint8 list from the buffer of it. Okay, let's move ahead. Okay, now comes the uint8 list. So uint8 list, why did I use it? Is because it's very memory efficient. So first thing, that it stores the images in a contiguous memory. So we don't need to hop in, so this processor doesn't need to hop in the memory to find all the pixel data. It's in a contiguous memory location. We get on the first byte and we can find all the memory data right away. The next thing that is very good with this uint8 list is it's just a comparison between uint8 list and the list of ints. So if we are going to put the same data in uint8 list and the same data in list of int, so uint8 list is taking 8 bytes and this list of ints taking 64 bytes. So that's where, so we need list of int for badge magic to convert into a bitmap, because Flutter does not support bitmap. So we need list of ints, a 2D list, but we are doing it at the very end. Before that, we are just handling everything in uint8 list, because uint8 list takes 1 byte to store each element, whereas integer is going to take 64 bits. So that's why I used uint8 list. Maybe there could be a better approach also. And this is something that I saw in one of the open source repositories, where this person was just storing the images in a form of uint8 list. So what does he do? He took that image and he processed it, decoded it, and took it in the uint8 list and saved in the database directly. I don't know whether it was good or bad, but it was very interesting to see some other way to store the images, because usually what we do, we put the images in a blob in our GCP or in our AWS servers, and we just take it out from there. So it was some, I don't know what he does, but it sounds very interesting for me. So I added it here. And so yeah, so next thing is UI.picture. So UI.picture is also a low-level Dart library. And how it is different from UI.image is, UI.picture can be thought of a recorder. So how do we use an audio recorder? We start audio recorder, we say something or we sing something, and then we stop it. And then we can play it multiple times. In the same way, UI.picture works. What does it do? It records each vector lines that we draw on the canvas and sort of plays it back every time. So it's kind of a recorder for the images that we draw on canvas. So why is it helpful? Suppose we have a very complex graphics that we want to use each time, and we don't want to render it every time. So what we can do, we can actually start a recorder, record it, and save it once, and we can directly display it every time. So this is where UI.picture comes in. Oh, this is a small workflow of UI.picture. You can actually see a function in imageutils file also in Badge Magic, where I've done the same thing. It's actually everything that I've done in Badge Magic. I'm just showing it in a form of workflow. So you'll probably get an idea of how everything is happening. So we create a picture recorder. When we start recording, we draw the image on the canvas. Once the image is drawn, we end the recording. Now, manipulate is something, why I've added this manipulate is, I'll tell you later on, but you can manipulate images using UI.picture also, but it's very constrained. It's not like in UI.image, because UI.image you have access to each pixels. You can sort of change each pixel, but since UI.picture is just vector, is just a recording of the vector, so we cannot manipulate the image on that extent. So then we just manipulate, and then we can reuse it. We can sort of print the image on different screens as well. So that's it. That's what I said. So we can reuse again, and again. That's the advantage of UI.picture, and that's why we have used it in Badge Magic also. Okay. The next thing is image widget. So image widget is a high-level library in Flutter framework. So it's what you display on the screen comes from image widget. So whatever you need to process, you need to use the Dart libraries. So that comes in UI.image, UI.picture, uint8list. These all are Dart libraries. And when you need to display all these things on the app screen, then comes in picture the image widget. So image widget sort of uses UI.image in behind the scenes, because to render the images, as in the start I said, we need to have the access for each pixels, and UI.image gives us each pixels. So image widget uses UI.image underneath. So it has certain constructors. It's very basic thing actually. It has certain constructors, image.asset if you want to render the image from the asset. It has .network, .file, .memory. But I'll want to point it out, the image.memory. It's a very interesting constructor because what does it do? It already uses UI.image behind the scenes. But if we have a uint8 list and we want to directly display that uint8 list to the screen, then comes this image.memory. I'll probably have a code snippet, yeah. So I've added a code snippet for it in the end also. We just have a uint8 list image data. It's some uint8 list would be there. And we can directly call the image.memory constructor and pass those uint8 list into it, and we'll have the image rendered over it. Yeah, so this is a high-level workflow of how image widget in Flutter works. So what does it do? We take an image source. Image source could be asset, network, all those constructors that I've discussed just right now. So we take the image goes to an image provider, and now image provider will always check the image cache first. It tries to find whether that image is already in the cache or not. If it is in the cache, it directly displays it to the screen. If somehow it does not find the image in the cache, then it goes to UI.image, class of Dart, and then it renders the image and then displays it to the screen. So it makes, why it makes sense, because if we have an image and we are displaying it continuously, so it doesn't make sense to render it every time because it's going to put a load in the memory. If we have it in the cache, we can directly display it on the screen, and it will save a lot of memory, time, and it will speed up the application also. And next, yeah. So it's very basic stuff of how image processing works. I'll be having some, so I'll just explain you very quickly what this is. So we take these files, we take the image from any of the input source. We send the image to the decoder, where we need to decode these images. And then we need to process it. So like we want to increase the brightness or contrast, or we want to add effects, blur, crop, whatever we want to do. We can process the image and then encode it again and save it where we want. If we want to display it, then probably we'll display it directly without encoding it. So that's sort of whole flow of how images are processed in Flutter. And this is where how we are doing this. So it's just the constructor that I added: adjust color with brightness, adjust color with contrast, Gaussian blur. So Gaussian is just an algorithm for applying the blur, if you all know. So Gaussian blur comes as a constructor in it, and then we can crop the image very easily by passing all the coordinates, height, width, length, breadth, everything, and it does the same. So it's very basic stuff. It's nothing like you should not know. Okay, here comes how we are actually handling images in Badge Magic. So it's a high-level overflow, or high-level flow of how everything is happening in Badge Magic. So we first load SVG from the assets. There's this thing I want to point out. I'm saying load SVG from the asset because we are only supporting SVG right now. But there can be a way by which we can support other file formats also. Because the issue why I only used SVG is that image formats like JPEG does not have alpha scale. So there are RGBA. So sometimes some image formats misses some of the scales. So, and the Flutter is designed in a way that it tries to render everything by taking all the 4 scales. So there it was causing an issue, but we can probably find a workaround for that so that we can support all the image formats in it. So we load the SVG from the asset, we send it to the scale function, where we scale it to the size of the badge, because image could be in some other dimensions, but our badge is currently in 11 cross 44 pixels. So we need to scale down the image to that badge size. And then we trim the image. So trimming image is basically we remove all the white pixels from it. So suppose you have a very big image, a white frame, and image is somewhere at the top corner. So we don't want rest of the things. We only want that particular image over there. So we probably need to trim it. This all thing would not be necessary if we use the image that is currently in the format of the badge or the scale of the badge. But we'll probably not have these types of images. We need to support all types of images so that user can enter any image and we can scale and trim down to support the badge. So that's why we have these scale and trim functions. And then we directly convert it to the byte array and send it to a generate LED hex function. It's a function where we take the byte and convert it to its hex value. And then we directly send it to the badge. So that's kind of whole workflow of how image handling is happening in Badge Magic application. So loading images, basically we use the root bundle constructor of Flutter, and we load the image from the asset. And how we are loading the SVG file is we taking the SVG file as a journal string, and then we use the SVG string loader to pass the string as an SVG file. So we first take an SVG file from asset, we take all the string from it, and then we pass it to the SVG string loader that will generate an SVG file for SVG image for us. And then we create a picture info class. So picture info class, as name suggests, it's gets all the information about the picture. So it has picture, it has its dimension and other aspects of the picture also. So we save it in a global variable so that we can call all other functions using this. And then this is the scaling image. So the scaling is basically how we scale the image. We take the ratio, we shrink down the image to the batch size, and that's it. Scaling is pretty basic. So trimming image, I want to explain you how trimming happens. So I added this GIF of how it actually happening in Badge Magic. So if you can see all these 4 lines, so that's what we are doing. We are having for loops. We go from top to above and try to find the first black pixel or first colored pixel for it. And as soon as we found it, we stop there. So we do this for all 4 dimensions, and then we crop up and get the main image from the area. So that's how cropping is happening right now in Badge Magic. I have some screenshot. So this is a different application that I built at very start just to know which images are going to support in our Badge Magic application or not. So it will give you an understanding what is happening. So we have an original image of 80 cross 20, and then we scale it to the batch size that comes to 11 cross 44, and then we trim it. So after trimming, the image looks like something like this. And when we convert the image to the binary bitmap, we can find the image by following all the ones in it. So if we take the image and put it in a 2D list, we'll probably find the same image representing by ones if we map all the ones. So that's basically how everything is happening. Yeah, thank you, everyone. That's it from my side. If you have any questions, you can probably ask. Yeah.
So basically, you mentioned that we only use SVGs, right,
Yeah.
in Badge
Yeah.
Magic.
Yeah.
So is there any particular reason?
So that's why it's said in this in the slides that SVG is something that Flutter supports already, and the issue with other image formats, like I know for JPEG, it somehow misses the alpha channel. And Flutter, when rendering those images or trying to manipulate those pixels, it takes those 4 channels. So it makes an issue. We have to manually change or remove those particular channels. So for JPEG, alpha channel is not present. So we'll probably need to ignore alpha channel for it. So that's what I was saying. We can probably find a workaround for this and support all the image formats in it.
Right. Thank you very much.
Yeah. Anyone else? Yeah.
So if I want to hack on the Flutter application, where do I start? Is it in the Gitter? Is that where you used to communicate, or?
Yeah, you can ask at Gitter channel also. You can, if you want to add some new things, you can probably raise an issue in GitHub also, in the repository also. And we have very interesting issues open up over there also. You can check it out.
All right, thanks. I'll take a look.
Anyone else?
Any more questions?
It was boring. It was very boring. I guess so, because when I was preparing the presentation, I somehow figured out I went too technical. Previously, I had some these code snippets also, but I removed them at the very end because I don't want to get it very technical. So I hope you guys are not bored. Yeah.
Hello, I have a question.
Yep.
When you downsample the image, you're first scaling and then trimming. Why don't you do?
Come again.
I think in your last slide.
Yeah, just a second.
You are probably the last slide, I think. Oh, sorry. Yeah, this one.
Yeah.
One. You're first scaling and then trimming.
Yeah.
Will that cause any loss of features?
No.
If you do it the other way?
So I'll tell you one thing. I tried the other way also at the starting. I tried trimming it down and then scaling it, but I still cannot figure out why, but the images are getting broken every time. So it's kind of hit and trial for me at that time. So what I did, I first tried trimming it down and then scaling it, then images are getting broken every time. So I reversed the process, I scaled it and then I trimmed it and everything worked fine. So it's something that I did like, oh, okay, this works. I should probably keep this.
That's good.
Yep.
So the process here is you are streaming a vector image. So
Come again.
Vector image, SVG is vector.
Yep.
Yeah. So did you try to scale, trim image, trim bitmap image? Did you try it?
So come again. I didn't know.
Yeah. There's bitmap and there's vector image.
Yep.
Yeah. So did you try to scale the? How do you scale? How do you trim the bitmap image?
So trimming bitmap image, I haven't tried it, but we can probably do it. I guess so. So what would be the issue? I don't think so there will be an issue. We can probably do it. So bitmap image will probably be more easy to trim it. If you are just asking about trimming function, it would be probably very easy to trim it. So I guess so we can do that. So there's a lot of ways to do things actually. This is just one way. It could be a very much better way to do this thing. So any one of you can try and just change the way that everything is happening. That's how open source works actually. So anyone else?
Any more questions from
I
the
guess
audience?
so. No. Yeah. Thank you. Thank you.
Okay. Thank you very much, Jhalak.